Dear students, now we are again in a new video for the Descriptive Statistics course. In this video, we will start chapter 3 for describing data. If we recall the definition of statistics we that the statistics is collecting, organizing, presenting, analyzing, and interpreting data. We have already in chapter 1 know how to collect the data and the various types of variables and how to deal with every type of variables. Then in chapter 2 we covered how to organizing and presenting data and show how you can gain useful information from raw data by organizing them into a frequency distribution and then present the data into a various graphs. In this chapter, we will show a statistical method that can be used to summarize the data. In this chapter, we have three main measures. Number one, the measures of central tendency, or what's called the measures of location. These measures will be introduced in this chapter and in the first part of the chapter and shows us what is the location of the data and what is the value that all the data surrounded around it. So we will introduce various types and the most common types of measures of locations or measures of what's called by measures of central tendency, that is the mean, median, mode, weighted mean, and so on. Another type, which is the measures of variation. Also, it's called the measures of dispersion. And this measure is very useful to know how it is spread of the data in the values, and the values are varied. So we will use the measures like the range, the variance, and the standard deviations to measure how is the dispersion of the data. Finally, in the last part of this chapter, we will use measures of positions. Measures of position tell us how specific data values fall within the data set or its relative position in comparison with other data. That's the most common measures of position that we will take, say percentile, decile, or quartiles. Here we will start by the first part, that is the measures of location, or what's called by the measures of central tendency. Please, we'll first begin with two main definitions and two main useful meanings that is common in these three measures. The difference in between parameter and statistic. Here the parameter is a measurable characteristic of a population, but the statistic is a measurable characteristic for a sample. Here this means that measures that found by all the data values in the population, I mean that I count all the population and no one is excluded. All the data values is included, so the measure that will appear in this case will called a parameter. A parameter may be a measure of location, a measure of dispersion, a measure of position, but this called a measure of parameter. This measure will be parameter because of introduce a measurable characteristic of a population. But if it introduce a measurable characteristic for a sample, it then will called a statistic. So measures that obtained by using the data values from a samples is called a statistic. This is a very main important concept, so you should know by these parts. Now we will introduce the central tendency measures or the measures of location. The purpose of a measure of location is to pinpoint the center of the distribution of data. This means that if I have values, I want to know what value that the data is surrounded on this value. What is the pinpoint of the center? So we have 5 common methods and 5 common measures that used to know the central tendency for the data. The first one is the arithmetic mean, and the second one is the weighted mean. Then we will use the median, and the fourth one is the mode, and finally the geometric mean. So these are the common methods. Of course, they are more than measures, more than 5 measures for central tendency or method of application, but we in this course concentrate on the 5 most common for the central tendency. We will begin with the arithmetic mean or the mean. The arithmetic mean is the most widely used measure of location. It requires a scale interval. Recall again the 4 measures or the 4 scales. We have an interval scale. This means that the mean can't be used in the case of nominal measure or the ordinal measure. Only an interval or a ratio scale that we can use the mean as a measure of location. So the measure characteristic of the mean that we use all the values that is used, that is in the case whatever these values are, population or a sample, we use all the values. The mean is unique. This means that we have only one mean. After calculations you have only one result, so we have the mean is unique. Number 3, the sum of the deviations from the mean is 0. This means here in this chart, if we have 3 values, 3, 4, and 8, and we want to know the mean for these 3 values, so the mean will be the sum of the 3 points, 3 plus 4 plus 8, over the number of the points, which is our 3, so the values summation over 3. But what is meant by the sum of the deviations from the mean is 0? This means that if I have the mean value equal to 5, which is the result of addition 3 plus 4 plus 8, which is 15, divided by 5, which is 3, okay, 3 plus 4 plus 8 divided all by 3, that's equal to 5. So the mean here will equal to 5. What is the mean of the sum of the deviations from the mean equals 0? This means if we find the deviation from 5 for these points, the difference between 4 and 5 equal to 1 in a negative direction. So it's equal to -1. And the value 3 and 5, the values in between equal to 2 in a negative 4 direction, so the value is equal to -2. And the 5, the space in between 5 and 8 equal to 3 in a positive direction, 2 equal to +3. So if we add 3 plus -2 plus -1 should be equal to 0. This means that the sum of deviation from the mean is equal to 0. I mean that they're far from the mean. If we added the value one for the mean, all equal to 0. This was meant by the sum of deviation from the mean equal to 0. And finally, another characteristic of the arithmetic mean is it's calculated by summing all the values and dividing the value by the number of the values. That's of course what we already do to get the mean equal to 5. First, we will take the population mean. For the ungrouped data, that is the raw data, the population mean is the sum of all population values divided by the total mean number of the population. If we have the population, say, in the Department of Statistics, we have 10 students, so the population in this case will be 10. If we want to get the average for their results in a mathematics exam, we will add the 10 values and divide it by 10, so we will get the mean value. So we have the all population and then in this case, the mean is called population mean. Population mean is represented by mu. This called mu. Mu, it's a Greek lowercase and called mu and represents the population mean. And n, capital N, is the sum of the number of the values in the population. And x represents any particular values. And summation, this means the sum, this value, this sum, this called sum. And sum x is summation for x values in the population. So if we want to get the population mean, we represented it by mu. Let's take an example for the population mean. There are 42 exits on 1 up to 71, 75 through the state of the United States. Listed below are the distances between the exits in mil. So what is this information? Why this information is a population? First, the question. Ask why this information is a population. Why it's not a sample? Because if you count these value, you will find it 42. If we count these values, all these values, you will find it equal to 42. So we have all the values here, not a sample or not a portion from it. So this is the values in our population. What is the number of meals between exits? Now we can add all the values and divide it by 42 to get this value. So the answer here, the population, because it's consider all the exits in Canada. And what is the mean number? Equal to mu. We refer as mu because it's a population mean, and sum all x divided by capital N, which is equal to 42, and sum all values from 11, 4 plus 10 plus 4 plus 9 up to 2 plus 2 plus 1, and added them up in the numerator divided by 42. That is the total population number, equal to 4.57, which is the value of the population mean. Now let's move to the sample mean. The sample mean for the formula is the same for the population mean, but in the samples it differs, because in the population mean we refer by the mean by mu, but here in the sample mean we refer by x bar. So x bar is the sample mean and a small n is the number of values in the sample. For the ungrouped data, the sample mean equal to summation for all the sample values divided by the number of the sample values and noted by x. Let's take an example. SunCam is studying the number of minutes used monthly by Chileans in a particular cell phone rate plan. A random sample of 12 Chileans showed the following number of minutes used last month. So we have a random sample. Random sample. He already said a random sample. We have only 12 value. So the sample mean will equal to x bar, because it's a sample mean, so denoted by x bar, summation the values of the sample or the values starting with 90, 77, 94, 89 up to 83, and divided all by 12 equal to 97.5, and this is the value for x bar, or what's called by sample mean. Now we will move to another important measure. The second measure we have here is what's called by weighted mean. The weighted mean is a special case from the arithmetic mean. It occurs when there are several observations that have the same values. Now we have several observations that have same values. For example, suppose that we have a restaurant that have three sold that's medium, large, and big size soft drinks. For these values, 0.9, 1.25, and 1.5. And Here in the last 10 drinks sold, 3 were median buy, and the one median equal to $0.9. Then 0.9 plus 0.9 plus 0.9, and he sold 4 large, and the one large is sold for 1.25. So we have 4 values equal to 1.25. This means that we will add 1.425 four times. 1, 2, 3, 4, because he sold 4 large, and 3 were big sized, and 3 were big sized, and the one of big size is sold by 1.5. So we will add 1.53 times here to get all the values that are similar. Now note that we have a similar observation and have the same values. The 0.9 repeated 3 times, 1.25 repeated 4 times, and 1.5 repeated 3 times. We will add all and divide the sum by 10 to get the x bar and the mean sample mean equal to 1.22. But it's more easier to find the mean selling price to determine the weighted mean, that is multiplied by each observation by the number of times it happens. The 0.9 happens 3 times, so we multiply 3 by 0.9, and the 1.25 happened 4 times, so we multiply 4 by 2.5, and 1.5 happened 3 times, so we multiply 3 by 1.5. We will multiply each one by the number of times it happened, and this is what's called by the weighted mean. And also we will divide it by the total sample number, which is equal to 10, because we have only 10 values, and divided by 10, we will get the same result for x bar, but with easier way. So we have a rule for weighted mean, that's the weighted mean, which is noted by x bar, and we have here w, x bar w equal to w1 x1. This means the weight 1 multiplied by the first observation plus the weight 2 multiplied by second observation up to the weight n multiplied by nth observation, and divided by weight. Here, dear students, be careful that we divide by the weight. We divide by the weight again, not the observation's value. We divided by the weight. This part, many students may be maybe use values, not the weighted, but we in the denominator here we divided by the weight. For example, the Qatar construction company pays its hourly employees these values: $16.5, $19, $25 per hour. There are 26 hourly employees, and 14 of which are paid by 16.5. Then we have 26 employees. They are 3 parts. 14, they are paid for the first amount, and then 10 paid for 19, and then only 2 paid for 25. So what is the weighted mean, or what is the mean hourly rate paid for the 26 employees? How to get this value? By using the weighted mean, which is noted by x bar w. This is by multiplying the weight 1, which is 14, with that we have 14 employee, multiplied by $16.5, plus weight 2, which is 10, multiplied by $19, plus weighted 3, weighted 2, multiplied by 25, and divide all by the sum of the weight 1 plus weight 2 plus weight 3, which is equal to 26, which is the total sample size we have. So the weighted mean in this case will equal to $18.11. Okay, let's move to the third measure that we have here in the measures of location or measures of central tendency. What is the median? The median is the midpoint of the values after they have been ordered from the smallest to largest or the largest to smallest. Just we order the values first and find the midpoint. Properties of the median that we have already, the properties of the mean. Now we want to know what is the properties of the median. First, there are a unique median for each data, like the mean. Also, the mean was a unique, not more than mean result in the same case. Number two, it is not affected by extremely large or small values, and it's therefore valuable measure of central tendency when there are error occur, such values occur. This means, what does number two mean? Please concentrate. We have values, say if we have values 3, 2, 5, 6, and 100. Now we order these values 2p, 2, 3, 5, 6, and 100. And the median here is a midpoint, which is the point that in the mid, which is 5, and not affected by extremely large values like what's 100. This value may be not true. Maybe it's 10, but who wrote it 100. It's not affected by this error, but it's only a measure for the values that's in the middle. This is what is meaning by number 2. Number 3 or property 3, it can be computed for a ratio, interval, and ordinal level. This differ from the mean because the mean it's for the ratio and interval level only and ordinal level not included. Here, the only measure is not included for the median is the nominal measure. Number 4, it can be computed for open-ended frequency distribution if the median doesn't lie in the open-ended class. This means that we have, if there are many values, we can compute this for median for the open-ended frequency distribution. Here we have an example for the median in the case of the examples. Now, the first example that here, the ages for a sample of 5 colleague students are 21, 25, 19, 20, and 22. Find the median. First step for finding the median is arranging the data in an ascending order or descending order, but we should arrange data. So we will find that 19, 20, 21, 22, and 25. And here the median is the midpoint, which is equal to 25 because there are 5 values and we have the midpoint value is equal to 21. So the median in this case equal to 21. But if we have even number for the values, not an odd numbers, this like this. If the height of 4 basketball players in inches are 76, 73, 80, and 75, what is the median in this case? Now we haven't a midpoint here. First of all, we first arrange the values. So the values equal after arranging it in an ascending order equal to 73, 71, 76, and 80. But we haven't here a midpoint. What we can do? In this case, we will add up the two values in the middle, which is 75 plus 76, and divided them by 2. I mean, maybe we get a mean for the two values in the middle to get the value equal to 75.5. This is the values for the median in the case for the values is an even values, not odd values. Let's go to another important measure, which is a mode. The mode is the value of observations that appears most frequently. That is, most frequent number. The most frequent event that happen is the mode. Here, if we have this graph and the value is occurred maybe 110, here 350, here to 180, here 80, here 50. What is the most common? What is the most common? The most common here, which is happened 340, 50 times. So the mode here adds this. Okay, let's take an example. Using the data regarding the distance in miles between exists on 1 up to 75 through the information is repeated below. What is the model distance? What is the most common value? So we can organize the distance in a frequency table to know how the values are repeated. We find that number 1 repeated 8 times. We find if we count this here 1, 1, 1, we find it 1 repeated 8 times. And number 2 repeated 7 times. 2, 2, 2, and put the frequency here. And like the frequency distribution table that we have tally information and the calculating the frequency in the previous chapter. So we find the values from 1 up to 14, each value how many they are frequent. So and we count all the values, we find that 1 is counted and the most frequent number is 1 because it repeated 8 times. This means that we may have more than one mode. We can have two modes because if we haven't, for example, let's imagine that we haven't 1 and we haven't 2. Here 2 is repeated 2 is repeated 7 times and 3 is repeated 7 times. This means the most frequent have 2 values. In this case, we have 2 modes. 2 modes. This means that the mean is unique and the mode, the median, is unique. Only one mean, only one median, but we can have more than one mode. We can have 2 modes, can have 3 modes. It depends on how frequent is the number. Now let's move to the relative position of the mean, median, and mode. Here we have 0 squares, and we will use the squeeze and introduce the squeeze in later on in the chapter in details, but let's go to this part and find the relation in between the mean, median, and mode. Here we have the mean in this. If we calculate the mean and find it's equal 20, a mode equal 20, and the median equal 20. So the data is have this curve. The squareness are have the same 0 squareness because it's not skewed to the left or not skewed to the right. So the mode equal mean equal to median. Here, if the median, of course, all the time median is the midpoint and in the middle. And if the mode is less than the median and the mean is more than the median, so we have a positively squeezed, and which is have the tail here to the right direction, the tail to the right direction. But if we have the median, sure, always in the middle, but the mode is greater than the median, and the mean in this case is less than the median. So we have a left squeeze. A left squeeze means that the data, more data are in the right, and they are left squeeze here with like this. So this is the relative position for the mean, median, and the mode. Dear students, please study hard and solve more examples from your reference, and we will tackle many measures in later on this chapter. Now we just covered the four common measures, that mode, mean, a median, and a weighted mean. In the next video, we will take the geometric mean, and we will start with the measures of dispersion or variation. Thank you for listening.